7.3. It states, prove that TP is equals to PE. Thank you. Prove that TP is equals to PE. When will TP be equals to PE? Check TP. Check PE. When will they be equal? If T1 can be equals to angle E. If T1 can be equals to angle E, then it means TP will be equals to PE. Check. Thank you. 7.3. 7.3. Should look at the whole diagram. 7.3. Prove that TP is equals to PE. The answer is, the question is, when will TP be equals to PE? The answer is, if angle T1 can be equals to angle E. That's the way to go. Thank you. We've got our target at the moment. We need to prove that angle T1. Look at where T1 is. TP, TP, PE. T1 must be equals to E, the whole of angle E. And remember, we have proven that TEPB is a cyclic quad. TEPB is a cyclic quad. Very much interesting. So every time you ask a question, prove. The answer is when. I'll just have a cup of water for 2 minutes while you work it out, because I can see my voice is almost running out now. It's a bit tired. For the next 2 minutes, do number 7.3 for me, please. Let's carry on with solution. Thank you. I gave you 3 minutes to solve it. I hope you've managed. Remember what I indicated to you. I indicated to you that in 7.1 we have proven that TEPB is a cyclic quad. So, and remember, angle T3 is equals to 90 degrees. That is an angle subtended by diameter. That is an angle subtended by diameter. Therefore, if T3 is equals to 90 degrees, it means we are now in 7.3. It means angle T1 plus angle T2 also gives you 90 degrees. These are the angles on a straight line. Remember, T3 is 90. Therefore, T1 plus T2 is also 90. Because you add them all together, they'll give you 180 degrees angles on a straight line. Therefore, it means T1, if you make T1 the subject of the formula, T1 will be equals to 90 degrees minus angle T2. 90 degrees minus T2. Check T2. Check T2. 90 degrees minus T1 is equals to 90 degrees minus T2. And remember, B1 and T1, because we have proven that TEPB is a cyclic quad, T1 is also equals to B1. T1, maybe I should also indicate that T1 is also equals to B1. Remember, check. TEPB is a cyclic quad. What does that mean? It means T2 is equals to E1. T2 is equals to E1. Remember, T2 is equals to angle E1. Why do I say T2 is equals to E1? We need to provide a reason. T2 is equals to E1. Those are the angles subtended. Those are the angles subtended by same chord. Where is that? Let me check. T2, E1. Angle T2 is equals to E1. Subtended by chord BP. Subtended by chord BP. Check in this triangle. In this triangle, TEB. This angle is 90 degrees. This angle is equals to 90 degrees. Therefore, it means B1 plus E1 also gives you 90 degrees. E1 plus B1. They will also give you 90 degrees. Why do I say E1 plus B1 is 90? Because E1 plus B1 plus P is 180 degrees. Those are the angles of a triangle. So if you transpose 90 to the other side, it means you'll be left with B1 plus E1 being equals to 90. From that theorem that states angles of a triangle are supplemented. Then check. T1. We said T1 is equals to 90 degrees minus T2. T1 is equals to 90 degrees minus T2. Now I'm saying E1 plus B1 is equals to 90 degrees. Let me make E1 the subject of the formula. E1 is also equals to 90 degrees minus B1. 90 degrees minus B1. Check the two statements. T1, 90 degrees minus T2. Remember, T2 is equals to E1. T2 is equals to E1. Therefore, it will therefore mean T1 is equals to the whole of angle E. Then you conclude that angle T1 is equals to the whole of angle E. So if T1, if this angle is equals to the whole of this angle, therefore you draw a conclusion that AT, what is it? PT will then be equals to PE. Therefore PT will be equals to PE. And I think that gives us the solution to number 7.3.